So welcome to our statics of rigid bodies. So first we have to understand what is statics and what is a rigid body. So a statics is the study of the effects of forces on a body which are at rest and not accelerating. And then a rigid body is a body that is not experiencing any deformation, which means kahit nalagyan natin ng force yung isang bagay, parang hindi siya nababali, hindi siya nabumabaluktot. So yun yung assumption natin na yung body na ginagamit natin ay rigid on this topic. So now we have these kind of forces. We have the tensile force, which is yung pahila na force, ng pa-pull. For example, sa tali, sa mga low bid natin. So puro pa-pull, hindi siya pwedeng pang-tulak. And then we have the compressive force, which is yung pa-push naman, no? Pang-dagan. No? So yun yung mga forces natin. Compressive at saka tensile. So ano na may concurrent force? So yung concurrent force ay force siya na nag-act on the same point. Different direction pero from one point lang siya nanggagaling. Parang yan yung given na nakita natin. Ano? So for example, itong tao na may hawak na aso, no? Iba-ibang direction yung aso pero galing lang siya doon sa kamay niya yung tali. So dito, from one point lang. So now we have component naman na tinatawag. So yung component naman ng isang force, for example, yung isang force na naka-diagonal. No? So meron siyang tinatawag na component which is along x and along y. Para natin siyang tinitreat as triangle. No? So meron siyang leg na along y at along x. So yung force natin na 10 Newton, parang in-assume natin siya as distance na 10. Kinonvert natin siya ganun to solve it. No? So same Pythagorean theorem yung ating way to solve it. So we have, or the SOHCAHTOA, we can use the SOHCAHTOA. So 10 Newton sine 30 degrees, yun yung ating 5 Newton na x component, y component niya. Then we have 10 Newton cosine 30 degrees na kanyang x component. So we have naman tinatawag na resultant force. So yung single force na yun na obtained by combining yung forces na nag-act dun sa body. For example, so see this illustration, di ba yung tao natin, halimbawa, no, may hawak-hawak siyang tatlong dogs. And then in different direction, tumatakbo yung mga aso. Hindi naman siya pupunta in three different direction. Na pupunta siya into one single direction na parang yun yung result ng tatlong hila ng aso. So like nung drawing na to, no? So para siyang isang malakas na hila na in one direction lang. No? In a single direction. That is the resultant. So yun naging result ng hila ng tatlong dog. So pag kinambay natin yung F1, F2, and F3, pwede natin siyang isolve as a single force na tinatawag natin resultant. So for example, ito, yung dalawang force, we have force F1 and F2 na isang 100 Newton and 80 Newton respectively with that angle. No? Hinihila niya yung bakal or yung sa wall, ano, diba, merong patungan dun sa wall. Hinihila niya. Hindi naman mahihila yun ng mahahati yung bakal na yon into pataas at sang pababa. No? Mahihila siya in a direction na pag pinag-combine natin yung force na F1, F2, yun yung direction na mapupuntahan niya. So we do that by computation. So we solve it by component. There are many ways kapag dalawa lang na force na ganyan. No? Pwedeng triangle, parallelogram. Pero at this time, I'm gonna teach you yung component method. Since ito yung ginagamit sa usually hanggang sa dulo na, no? Ito yung mas gamitin. Lalo pag marami ng forces, hindi natin ma-apply yung iba. Mahirap na. Ito na lang. Component by component. So first, we get the component ng magkakaibang force. So yung F1 muna, we get that 100 Newton cosine 30 degrees. That is 86.60 Newton. So yung Y component niya is 100 Newton sine 30 degrees, which is 50 Newton. Now we get F2. So we have 80 Newton cosine 340 degrees, 75.18. Then we have 80 Newton sine 340 degrees, negative 27.36. So may reminder po dito na pwede natin gamitin yung 20 degrees na given. However, we just have to remind ourselves na nasa ilalim yun, nasa fourth quadrant. Kasi kapag 340 degrees yung ginamit natin, look at F1y, no? Automatic na magne-negative 27.36 yung result. Ibig sabihin, yung direction niya pa nasa, yung y natin is nasa down na direction, nasa pababa. So kung 20 degrees yung gagamitin natin, lalagyan na lang natin ng negative. Kasi positive yung magiging lalabas nun eh. Kung 20 degrees yung ginamit natin. So kaya 340 degrees na yung ginamit ko. Para automatic, meron na siyang negative sa result. So bakit ba kailangan natin yung negative na yan? Same magnitude lang naman, magkaiba lang ng direction. Ang negative and positive signs ay nag-i-indicate siya ng direction. Kasi in resultant, ang ating solution for resultant is parang distance formula. Or sabi ko nga parang Pythagorean theorem na c squared is equal to a squared plus b squared. So we get the square root of our component x and then y. So pinagpa-plus natin yon para sa x component ng resultant natin, we just get the summation ng lahat ng forces x. We have f1x saka f2x. So yung kanina, 86.60 plus 75.18. So we get 161.78 Newton. So para naman sa lahat ng sa ry natin or yung y component or the vertical component ng ating resultant, so we have to get the summation ng lahat ng fy. So then we have f1y tsaka f2y. Now since we have 50 Newton doon sa ating f1y, now dito na nagmamatter yung negative sign kasi nga yung 50 Newton ng f1y ay pataas. Ngayon yung 27.36 Newton ng f2y ay pababa, kaya siya negative, meaning pag kailangan siyang pag-minusin. Kasi para siya naghihilahan na tao no? Isang pataas, isang pababa. So magkokontrahan sila. So mag-minus yun. Unlike kapag same sila ng direction na parehas silang pahila pa forward. So mag-a-add yun. No? So kung magkaiba ng direction, we subtract. Kaya importante na alam natin kung nasaan quadrant, kung saan siya papunta, pahila ba siya pababa, pataas, patulak ba siya, or pahila. So, kasi pinagma-minus natin. So, we get 22.64 Newton para sa ating Ry. So, to get the resultant, so substitute lang natin sa formula na Rx squared plus y, Ry squared, so square root nila. Then, we get resultant as 163.36 Newton. Meaning, yung dalawang force na yon, no? So, yung kanyang lakas, so, meron siyang 163.36 Newton as 1. Yun yung lakas niya. Ngayon, yung direction, we get the angle of the direction. We have the tangent inverse ng ry minus rx. Parang lang din, Pythagorean theorem, or the SOHCAHTOA. So we have the tangent inverse ng 22.64, which is yung y over rise over run, which we have the rx, which is 161.78. So we get 7.97 degrees north of east, meaning nasa first quadrant siya. So yung direction kapag hinilan ng forces na yan, nasa first quadrant with an angle of 7.97 degrees Newton. So yan yung magiging direction niya in a single force. Now for our example 2, we have two loads are applied as shown to the NC of boom BC. So determine the tension in cable AC, knowing that the resultant of the three forces exerted at C must be directed along BC. So yung tension sa A, cable AC, tapos meron tayong force sa 60 pound at 40 pound. So yung result nilang tatlo kapag naghilahin sila. So darang nadadirect siya dun sa may boom na BC, no? So papunta siya doon. Parang ganito. Now ito naman, so yung boom BC natin ayan, naka-along na siya sa x-axis. We do a rotated axis. Ni-rotate na natin siya para hindi siya mahirap i-solve. Kasi kapag ganito, naka-slant yung ating BC, magkakaroon tayo ng component na x and y. Mas maraming unknown. So what we do is parang inikot lang natin yung drawing. So try to imagine that. Iikot natin yung drawing. So ayun na yung BC. So yung angle siya pa din. So pwede nyo itagilid yung inyong cellphone kung nasa cellphone kayo para ma-imagine nyo na mabuti. So by that, we can now solve na yung resultant ng AC, 60 pound, saka 40 pound, pag pinagsama-sama natin, yun yung BC na lalabas. So meaning yung X nung A, yung X nung 60 pound, saka X nung 40 pound, ay equal siya doon sa BC. And the same with RY must be 0 naman, since walang tayong resultant. Since nakatagilid na siya, walang tayong resultant na Y. So RY must be 0. So we get 0 is equal to tension at AC sine 80 degrees. Then minus yung 60 sine 40 degrees minus yung 40 pound sine 60 degrees. Then we get this by transposition, and then we get the value of tension at AC, which is 74.70 Newton. Okay? So that's already the answer. Hindi naman para namang ibang hinahanap, kundi tension lang sa AC. So masasolve natin siya ng by rotation of axis kasi nga nag-zero na yung sa Y. Unlike dun sa isa kanina, kung ganyan natin siyang isosolve na naka-slant yung BC natin, wala kasi tayong body ng BC, so we do not know. So, mahirapan tayo mag-solve for that. So, mas madali kung i-rotate natin yung axis like this. So, that's it. Thank you. And for more videos about statics, just watch it on YouTube.